So we discussed the gateways are used to connect to different networks. So when we have computers in a network, we need a way to uniquely identify each of these network computers. Now, one way is use of IP addresses. We call logical address, which means it might change, it's temporary, but it can be used to uniquely identify. So it's a 32-bit number, and there are 4 8-bit numbers separated by dots or periods. So this is called IP version 4. So according to 32 bits, you can connect about 4 billion devices. But the latest one is called IP version 628 bits. Right? You can connect huge number of devices there. Right? Now, the IP version 4, 32-bit IP address can be divided into 5 subclasses, like class A, class B, class C, class D, class E, and so on. So depend our requirement, we can choose whether to have class A, class B, class C, and so on. But there are some different properties. So let's first look at how these 32 bits, that means 4 bytes, are separated in different classes. Now, what you need to remember is class A, always you have 2 network ID and host ID. So for class A, 1 byte is reserved for network ID and 3 bytes for host. So class B, it's equal, so 2 for net and 2 for host. C, 3 for net and 1 for host. So it's very simple to remember this. So 1 byte for net, and here 2 bytes, 3 bytes. D and E actually used for special purpose, like first of all, D for multicast addresses. Remember, we talked about multicast yesterday. That means when you're sending data from one machine to another machine, so we call unicast. And when you are sending one to many, we call multiclass. And finally, class E is for reserved, which means for experimentation. So this is what is reserved. Right. Then let's go into detail. Now, first of all, you need to remember class A contains large number of hosts. Why? Class A, you have 24 bits for host, which means if you need all possible combination, it will be 2 to the power 24. So it will be 2 to the power 24 approximate number of hosts. We have to reduce 2 here because like there are 2 addresses which is very specific, right? So because of that, we have to remove. So that means 0.0000 and 127,000 is a special ones. They are not counted. So that's why you subtract 2 here. So approximately we can have like 16 million hosts, right? And then another thing that you need to remember is a subnet mask, or simply we will say marks for class A. The mask means when you have like all the network IDs, the first 8 bits to make it to ones, and all the host bits to 0, we will get the default mask for class A. So that is 255,000. So these are the things that you need to remember about the network addresses. So that's class A. Now the second one what we discuss is class B. Okay, one thing I forgot. So in class A, the first bit should be 0, which means although you have 8 bits, for the network, you have to use 17 remaining bits. Right? The range you need to remember, the range of IP address goes from 1 to 126. So if you have 1 and something here and 120 something here in the valid range, so that belongs to class A addresses. Right. Okay. Right. Now the next one is class B. One thing you need to remember about class B is, now in class B, you will have 16 bits in the network size, host bit again 16. But the first two bits we said it should be 1 and 0. So that's why the remaining 14 bits we have to use for the network, right? And then like in earlier, number of hosts are 2 to the power 16 minus 2, like in previous case. So this will be 65,534 hosts you can have. Then IP range is going from 128.0.0.0 to 191.255.0.0. Subnet mask, like in earlier case, the first 16 is 1, the second 16 is 0. So you will get the subnet mask as 255.255.0.0, right? So that's what we are getting about the subnet mask for all these classes, right? And then right, we need to talk about, okay, class C. So let's start with class C today. So we will have class C. Okay, we'll start with class C now. Now, first of all, uh, you will have class C. Sorry. So we have network ID 24 bits long and the host ID is 8 bits. So usually this is a sign for small size network. I don't know whether I have mentioned this for the earlier one. Oh, yes, I said, right? So the class B, we said it's for medium to large size. Class C for the large size network. We didn't mention it like that, right? But yes. So let's start with that one. Let's write down under class C, right? We can say that class C IP addresses IP address ADDRESS IP address belongs to class C are assigned to small size networks, right, that we have discussed earlier as well. The next one you need to remember is number of bits allocation. We said 3 bytes for network ID and 1 byte for host ID. So we can say the network ID is 24 bits and host ID is 8 bits, right? So in early cases also we have discussed this. So the first 3 bits, in this case, first 3 bits are always set to 110. So not like in earlier. So this time it's 110, right? So that means 3 bits gone out of 24 for the network. So we have remaining bits. The remaining 21 bits are used for network, are used to determine network ID. I hope that you remember, because we said it's 2 bytes each, and then that means, right? Sorry, 3 bytes and 1 byte. So that means 24 bytes. So 24 bytes and 8 bytes. But first 3 bits are always set to 110. So you have remained with 21 bits. The 8 bits used to determine the host IDs. The default subnet mask for class C is, how do you get this? Subnet mask, I told you, all the network bits to 1. So that means we have 1, 1, 1, 1, 1, 1, 1, 1. Yes, we have 8 bits, 1, 1. And finally, you will have, right? Which means we can say this is 255, 255, 255, and 0. So that is the default subnet mask. So we can say for class C, there are, right, 2 to the power 21. That means 209, 2,097,152, 152. So this many, network addresses. Two to the power 8 minus 2, right, host addresses. So this is, you can say, 2 to the power 21, and this is 2 to the power 18 minus 2. By minus 2, we will use first and last IP addresses are special. Host addresses. Right? The IP address range, again, you need to remember this one. IP address range for class C is 192.0.0.0 to 223.255.255, right? So these are the valid ranges. You can draw this about the diagram for class C. You can see the first three bits 110 and 21 bytes remaining for the network and 8-bit for the host. IP addresses are reserved for multicasting, right? And the IP address range, we just put this. This is, I don't think you need it, but anyway, 224.0.0.0, right? 239.255.255.255, right? Then class D, sorry, class E, IP addresses are reserved for experimental and research purposes. So the IP range, IP address range, it should be range, right? So it start with, for E class, 240.0.0 to, it's go for 255, 255, 255, 254, right? So I have given all the ranges where you need it, right? Right. So now let's look at some more details about the flow classes. Right. So now we discuss A, Class B, Class C. I will give a small exercise you to work on. I will give you 5 classes. Under 98, 12, 3, 8. Right? I want to find out which one is belongs. Fourteen, 25, 36, and 65. Then 225, 25, 31, 60. Balagan, Balagan. Where 38 and 50. And then 32, and then 47. Right. So just identify what are the respective classes. How are we going to get IP addresses? There should be somebody who should give these numbers, right? It could be class A, it could be class B, it could be class C, and so on. We have to have somebody to give us these IP addresses, right? And all the hosts in the same network, all the hosts in the same network, they are assigned the same address prefix. Right? Address prefix are assigned by central authority and are obtained with internet service provider. So remember that. So we have to get from these addresses from internet service providers, and within the network, right, each host is assigned a unique suffix locally by the network administrator. Right? There are few people are assigning IP address. First of all, we are getting these IP addresses from the internet service provider. Now, for example, Dialog or Mobitel, right, or SLT, we are getting these addresses from them, right? Now, once you get that one, within that one we have to give network, right? In the network you have to provide different values. So these given by the network administrator. So shall we take down this one? So net IP address assignment, we have to tell how we get, right? Right. So let's write down. Let's take down IP addresses. IP addresses are assigned by internet service providers. So who are the ISP service providers? We can say example. So who are the ISP providers in Sri Lanka? So for example, in Sri Lanka, we have Dialog, right? We have Mobitel, right? We have Hutch and so on, right? So we can see there are different services providers are there, right? When we say Mobitel, then it includes telecom as well. Okay, right? Many of them are there. So we have Airtel, Etisalat, right? Sri Lanka Telecom, and so on. Right? So they are the ones who actually provide us the IP addresses. Right. Let's write down all hosts. Now I told you, like, right? Now we have hosts and network IDs. What do you mean by host ID? Right? Host ID. So host ID means it's uniquely identify a particular host, right? Uniquely identify particular host. Okay. So there are, different hosts are in a network, right? So different hosts are there, right? So any device, we have IP address, right? That we have discussed. So host mean in a device which can receive, right, and also like contacts with the other devices. Now, for example, if you take email server, now in email server, we can both receive and send emails. So we can use this as a host, right? So usually we say hosts. So part of the network, I told you, we have, you know, part of the network IP address, you see the host ID. Right now, all host in the same network, all host. So there are many servers or many hosts in the same network. So all hosts in the same network are assigned the same address, same address, same address prefix. Right. That's about the hosts. So address prefixes are assigned by central authority and update from this ISP. So ISPs gives this, right? Okay. Right. So that's about the assignment of IP addresses. Now let's look at subnetting. Right. So let's look at how we can do this. Right. So subnetting means now we know we have only 32 bits. 32 bits means we have a limited ones, right? We have a limited number of IP addresses. So when you say subnet mask, we already discussed this subnet mask. When you say subnet mask, we always have a IP address. We have two parts. We have network and host. Now subnet mask is to identify these parts separately, right? So I told you already. So we have all ones, right? And then all zeros. So network ID, we have all ones and zeros for the hosts, right? So the network number and the host number have to be identified when creating a subnet mask, right? So subnet mask means creating an existing network to be operated separately in a small network unit, right? So you are going to create a subnet, right? which means we are going to create a small network. So for example, when we have class A IP addresses, we can have a small subnet. Okay. So that's what exactly we are going to do. Right. Now, for example, now if you take class A, so in class A, how many bits we use for network? Yes. So let's write down the topic. Subnetting. We can say subnetting. So this is the title, subnetting. Right. Let's write down. Subnetting is a process of dividing a large IP network in smaller IP network. Simple as that. So subnetting allows us to create smaller networks from a large single large network. For example, I told you in class A network, usually you can have 16 million, hosts, which we might not be able to handle. right? Now let's look at how we are going to do this. The first step of subnetting is identify network portion and host portion in an IP address. Right, now to divide, before we divide it, we need to know what are the IP addresses and what are the host, and that portion we have to know, right? So we already discussed earlier, right? We already discussed earlier what the default subnetting means, right? Right? So we can see it here as well. Now we can say the default, right? The default, we can say default here. Subnet mask is 32-bit number where network bits are set to 1, host bits are 0. Right. Let me give you an example. Identify the subnet mask default subnet mask for the following IP addresses. Right? So let me put 10, 10, 10, 10. Second one, 172, 255, sorry, 172, 168, 1.1. Then 192, 168.1.1. Okay, so can you let me know what are the default? What is the default subnet mask?